Could you repeat that?
Welcome everyone. My name is Hausel. I'm working for Typesafe. Today I'm going to talk about the framework 2.0. And I'm going to focus mostly on the Scala side because it's a Scala meetup, but I think it's worth emphasizing that the 2.0 has an excellent Java API.
Can I just ask you just to speak up a little bit?
Okay. So what I was trying to say that today I'm going to focus on the Scala side of Play, but Play has like a really strong Java API as well. So if you're into Java, you can start using Play to Java and then gradually switch over to Scala if you want to. But anyway, so before I'm going to talk about Play 2.0, I think it's worth talking about like Play 1.0 and what was the situation there, what's the history of the framework, and what's happening with the 2.0 release. Okay. So I'm not sure how many of you know Play 1.0 or like the previous version of Play. Few hands, either from the Java or the Scala side. Actually, both are I think interesting. But okay, so let's talk about Play framework of 1.0 because it kind of helps to put into perspective why 2.0 is necessary, what are the differences architecture-wise. So Play 1.0 was written by Guillaume Board from Zenexity, which is like a really cool French web startup. I really recommend if you have anything to build. And it was written in Java and mostly targeted like Java developers. The templating language was provided in Groovy, and around 2009 came the idea that like how could we support Scala as well. And that's when I started contributing to the framework, and I was really interested in the Scala support. But I also provided like other plugins as well for version 1. What was really interesting about the 1.0, and that's why I asked whether you guys had a chance to play with it, was this kind of developer console, which pretty much let you compile things on the fly. And because it was like a Java environment, it was like a really interesting new way of developing your application. Essentially what I'm talking about is something like you start the developer console, you go to the browser, you then switch to your editor, you make changes in your editor, editing Java files, switch back to the browser, refresh the page, and either you can see the result compiled or if there's a compilation error. And in the browser, you're going to see the error message highlighted, and then you can just go back to your source and start again. So what's missing from this workflow is that we use kind of like compile, deploy kind of process that we own both from Java and Scala side. How cool? I mean, it was like a really cool feature. However, like it required many kind of like custom hacks. So essentially, that really meant that like the 1.0, as cool as it is, it required like a specific kind of like runtime, which I would call like a specific Play runtime, in order to support this kind of like I don't know, special sauce or magic, which was pretty much kind of on the fly compilation, and also, for example, like your Java classes got like properties and like certain features were added with bytecode enhancement. But as you can imagine, that kind of required to build like pretty much like a whole platform. So instead of using the Servlet API, Play 1.0 was using its own runtime in order to provide this kind of hot redeployment. So it used a special compiler, it used a special class loader, and it used bytecode enhancement. And as you can imagine, in order to support all of these, like you really have to have that runtime. While it was possible to bundle up the whole thing and run it in a servlet container, it was still kind of like tricky to kind of run Play 1.0 on, say, like on a cloud service provider, set up or something like that. other than that, like Play 1.0 also had its own kind of like dependency management kind of system, which was not using any of the existing big Java kind of like build tools or dependency management tools, Enter, Maven, or Ivy, or anything like that. But it was using something specific, which again, like in certain organizations, of course, like it was like a hardware stuff. However, like the ecosystem like grew, a lot of people really liked the kind of the Play experience, which I couldn't really kind of summarize in, I guess like one way I would say that like it's really the user experience that we try to provide. I think that's kind of specific, so I couldn't really pinpoint it to a specific feature, but I think we really try to pay attention to, I don't know, to the small things, to the details that you should have your documentation ready when you're developing. The development experience should be as pleasant as running your application in production. And the other point I would like to make is that, like, so when Play 1.0 was written, most of the web frameworks were like these kind of big monolithic full stack frameworks, for example, React, Django. And what happened since actually with all of these frameworks, they started kind of this kind of idea that like how we could actually modularize our frameworks, because it's just too big. You know, a lot of people like start using traditional databases, or at least mixed in like NoSQL solutions. And so many of the kind of the standard features and many of the standard ideas that the whole MVC kind of like idea represented kind of like change over time. So what I mean is that like JavaScript became like really significant player. Like I mean, and the whole MVC product kind of like was extended with an extra layer, which is your front end, and also like a lot of sites are not using like traditional databases, and so there are things that kind of like change, and that's why the whole kind of modularization effort was taking place both, for example, in React and Django, but that was something that it also happened with Play. Now, that said, Play 1.0 is still like a really good choice, because it's, of course, it's much more mature than 2.0, but it has like different kind of like trade-offs. So that's the history of the framework. So I guess the question really is like, so why we came up with the idea that like we need to enter a new framework, and with kind of like breaking changes across the board and stuff like that. So that's like, I think usually like a good question, like why somebody would like to write like a web framework in 2011, and not to mention like a rewrite of next one. So that sounds kind of like, I guess, crazy, but I try to convince you that like it was worth it. Okay, so the difference is, and I really can like to summarize it. I think it's here. So the difference is really coming from the fact that like we need to adopt this Scala for the core framework as the kind of element language. Some of the things that previously we could achieve with, for example, bytecode enhancement and stuff like that, now Scala kind of provided ourselves. So why Eclipse 2.0? So besides the core was written in Scala, Scala also became like the first class citizen. So previously, Play 1.0 had just like a really strong Java API, and the Scala support was kind of like an afterthought. But with Play 2.0, the Scala API is a first class citizen. Besides, again, we'll be using Scala in the core platform heavily. The templating solution now, but I mean, actually you can plug in any templating solution you would like, but the one that Play provides out of the box is also written in Scala. We now are building on SVP, which is using actually Ivy under the hood, and we kind of like get to a point where Play is as standard as it gets. So what it means that like you can drop in Play as a dependency, all the requirements and the kind of like the special things that we had with Play 1.0 now are gone. So you really can play both as like a full framework and also as a library. We will actually talk about that a bit later. I mentioned like the importance of the JavaScript in the front end. So now this whole kind of on-the-fly compilation was extended with JavaScript compilation. By that I mean that like CoffeeScript, which is not really like compilation. So the whole idea is that like when you make changes in your browser, when you make changes in your editor, and then you refresh your browser, not only your Scala or Java classes will be compiled, but your JavaScript as well, within the same step. And the other crucial thing is that like because a lot of people now have like different requirements in terms of like modules and kind of various parts of like the framework that you need. Now we kind of created like a more kind of like modular system where there is a small tiny part which is a core framework, and everything else is pretty much like optional. You're not using databases, fine, you don't have to use it. You can just use the for module, or so it's kind of more like we try to provide this kind of like ecosystem of plugins, like for example Node.js has something similar, although I would rather not really bring in like any metaphors like that, but the whole idea is that so you have like a small core framework and everything else is implemented as a plugin. And the other big change was kind of like providing all this kind of async kind of ideas, mechanisms. By that I mean, for example, we have really serious like auto support. We can provide all sorts of kind of streaming APIs. WebSocket support. You can stream your content, whether it's just basically through a command service, or if you just want to stream essentially anything like an image, anything like that. Many of these things on this list, unfortunately, were just not possible with Play 1.0. So that's why the API change was and the whole kind of rewrite was necessary. But anyway, so just to go into a bit more details about the features. So as I mentioned, Play 2.0 is supporting both Scala and Java. What it means in practice, really, that you can be like a Java developer, and you pretty much wouldn't need to really interact with Scala if you don't want to. However, because Scala is part of the whole experience, dropping to Scala is really easy. So you can start your application, say, developing in Java, and then when you feel like you're comfortable with Scala, or you just want to try out Scala, then you can write, say, your unit test in Scala. But you don't have to use it. But it's available now. And I think the API quality is almost the same, so equally good. That the framework is still kind of stateless. The whole philosophy hasn't really changed. There are like a few frameworks that kind of like pushing more like the kind of the stateful idea, but Play in this, at least in this respect, is really close to kind of the traditional MVC frameworks because it's completely stateless. The only state that you can use is really just in a session is like basically just like it's an activity cookie. So anything that you can keep there, that's pretty much kind of the state that the framework kind of supports. And as I mentioned, the development console and the whole kind of compilation was extended with JavaScript and CSS kind of compilation. We can call CoffeeScript compilation. One of the benefits of using Scala is that certain parts of a web framework now can be compiled. So what are typical MVC kind of parts of like a framework? Like usually there is a part either within your classes or within a separate file where you say that like I would like to execute this piece of code when this specific URL is called. It's in a real Django situation, it's usually defined a separate routing file. In other smaller frameworks, sometimes it's bundled with within like the method that you're gonna call it, let's say as an routing file that we provide is actually compiled. What it means that, like, when you say that I would like to call the specific method with get, and then you define. So this is the specific router file I'm talking about. So what you see here is that when you try to compile your application, you define the routing in such a way that you define the verb that you want to execute. You're going to define the URL that you would like to execute, and then of course the underlying class and method. Now, what's interesting about this screen really is that, like, if you make any typo by referencing your class,
can you make it bigger?
Can you put it in
Because I don't think everybody can
I
see.
don't know how.
Can you zoom in?
I thought in Google Docs there was a way to set it in the presentation mode.
Yeah, I think that's the
Command
one.
Shift presentation will pull straight from.
Command Shift.
Using a Mac, you can paint shot shit.
I see. But anyway, so really long story short, if you make a typo in your routing definition, you're gonna get a compilation error, not like runtime error. Again, it saves time. Same goes for example, your template. So previously we had like a templating solution which was using Groovy. Of course, like if you made any mistakes in your templates, then you would just see it like after you kind of like compile classes and you call that specific template. Now because we're using Scala for templates, templates are also compiled. So essentially, most parts of your application are compiled. Your build file is compiled. Your routing file is compiled. Your JavaScript is compiled, and your templates are compiled. Other than that, we provide like really good like Akka integration. I'm not sure how many of you are familiar with Akka. Akka is like a really cool middleware that, by the way, has an excellent Java API as well. So you pretty much can write like a Play application and using Java, and you still can use, for example, Akka if you want to. But the kind of like seamless Akka integration I'm talking about is more kind of like stuff like where you can stream Akka messages, like actor messages to the response, or you can essentially send messages to another actor, that other actor would send the back messages, and in chunks that would kind of send this information to the browser. I will actually show a short demo about that. And all the kind of like other asynchronous goodness that I kind of like briefly mentioned. So for example, we have like a comment, WebSocket support, and all of these kind of like streaming like solutions we provided by like kind of like a design pattern that I think we lifted from Hausel, which is the enumerator iterative kind of idea that I will mention briefly, but I guess that's like a separate session altogether. But the main idea really is that, like, instead of thinking about iOS, something that you really can just like I don't know, observe from outside, that you really can create like specific design patterns so that specific consumers and basically mechanisms to kind of map certain parts of like that whole I/O processing to the, for example, to the response. But again, as I mentioned, I will try to talk about that briefly, but it's somewhat an advanced topic. Other than that, like Play also comes with like a functional and unit test runner. Again, both available for Java and Scala. We have like kind of like a plugin system. So if you wanna, for example, include I don't know, Spring, Juice, or whatever kind of like the support or MongoDB, then it's really easy to just create like a plugin and make sure that it's available for your application. And other than that, like we provide quite a few other kind of generic APIs for everyday like development. For example, we have like a small cache API. We have like a JSON, kind of like a JSON API. We have like a wrapper around like an async HTTP client, and we provide form handling as well. And as I mentioned, dependency management is now happening via SBT, which under the hood is using ID. So this is really just, I just wanted to show how this kind of on-the-fly compilation looks like. If this is not really working because of the resolution, I guess I can even demonstrate this. It's not that complicated, but essentially what happened here was that I made some changes in my source file. I switched to the browser, refreshed the page, and then this is the error screen I got. Of course, now I see that like the error was somewhere here, so if I switch back to my editor, then it's very easy to see what might be the problem. And this is like a kind of like a compilation error if something was wrong in routing by. Again, this is the place where you define which piece of code should be executed for what kind of HTTP request. And this is like a compilation error for like a template, just like a few words about the whole templating solution. So there are like, I don't know, 10, 15 different templating solutions just in Scala. I think in Java there are at least 35. So it's usually like really hard to get right, I guess. Everyone has his or her specific ideas. Like a lot of people like logic class templates, a lot of people still prefer like some kind of control logic in their templates. I think play is kind of sitting in between. We kind of like provide certain logic, but that's more kind of like just to make sure that we can output like HTML kind of like elegant like and also kind of like Typesafe way because it's using Scala under the hood. So certain Scala expressions are available. I wouldn't go as far as saying that like it's kind of like JSP, but I think probably the closest release that Ruby has this templating solution called ERB. I think that's pretty much the closest. That said, because everything is like implemented as a plugin, if somebody prefers one of the other 65 or I don't know, I'm just making this up, libraries, like it's really easy just to plug in yours. So it's usually like, I guess like it's a private thing, so who likes what and why. So I would rather go into there where this is the best for everyone, but we do think that like it strikes a good balance. And here like just like another screen I want to show where like the issue is with like JavaScript compilation. As you can see, it's the same error screen, except now your error highlighted is actually not in a Scala file, but in your JavaScript file. What's happening really behind the curtain when you hit compile? Well, actually, when the server is triggering like a reload, then we call Google's kosher JavaScript compiler and for example, JavaScript compiler as well. If there is an error, we try to present it in the same manner we present like normal Scala or Java or routing error messages. But this pretty much provides like a really unified experience for users because like whether you're working on the front end and just working on JavaScript or working on the back end, you can interact with this development console the same way. Okay, so I just wanted to show like how kind of like how serious we are about like providing like two equally kind of good APIs. So the way the whole framework is built, that like we're shipping about like 10-15 sample applications with the framework, which we kind of think that like going to give you a good idea of what you can do with the framework, but also you can use these templates as templates, so you can start building your application using these templates. We have about like 4 or 5 sample applications that exist both in Scala and Java, and you can actually directly compare the two kind of experiences, which I think is really useful. And as I mentioned, it's even possible to mix in the 2 languages within one project, so you can have one controller written in Scala and one controller written in Java, and vice versa. But this is this is just an example written in kind of Java, and this is the kind of like the same thing, just written in Scala. Just wanted to show this kind of like interesting thing that like you really have this kind of easy way to see which one fits your need, or like if you want to compare the kind of the Scala experience with the Java experience, then it's really easy, because we try to kind of provide like similar like APIs, but I mean similar in that sense that like as much as the specific language provides. Of course, in case of Java, there were certain things that we just couldn't do because of that language. And this is one of the kind of like the features that we're providing there, as you can from within like a test, you can fire up like a whole application and run your functional test. This one is actually JavaScript everywhere. The underlying engine is Google Selenium WebKit. I think it's Google WebDriver. I'm sorry. And you can either use like a command line engine, which is HTML unit, or you can plug in like Chrome or anything like that. And this test would run in context. By that I mean that like if you have JavaScript, the whole application will boot out, and then you can test it in context. It's not just like a unit test, which you of course also can write. But what I find kind of interesting about this is that because it's like I think it's a spec, it's kind of like a mixture of the kind of unit testing and kind of functional testing. Play's own kind of integration test suite, by the way, it's partly written with this framework. We also have like unit tests, but kind of combine the two, because we have a series like front-end test as well, where say you want to test whether the Ajax support is working or the comment support is working. You can't really test that easily without having an application that's running. So what's happening here is that like we fire up like an application on that specific port, and then we check whether in the response we're going to find that hello world there, and then we check other parts as well. So this is the kind of the functional test runner. All right, so I'm going to show like a few other demos, and then I guess like if you guys have questions or like that. So I mentioned that I would like to show like 5 examples, but I mean, time permits like two other examples. The best thing about these demos, and that's why I chose these, most of them are available online. So like after the presentation, you can play with them, so to speak. So the first thing I would like to show is this kind of like add-on that we created like at Typesafe. This one just demonstrates like how easily the new version of Play kind of scales down. So for example, if you don't need like a full-fledged framework, you just however want to use Play as like an HTTP library, then you can use for example like this library, which is like a standard normal kind of like SVT kind of project. So there is nothing Play specific about it. And as you can see from the API, is actually using unfiltered kind of extractor library. So it's kind of like, I guess we can see that like it's unfiltered on top of Play. So just emphasize the point that the main thing here is that Play is not just like kind of like a full-fledged framework, but you can use it also just like a web, like a front end for services if you just need HTTP layer, but you don't need like full frameworks, and you still can use Play either like directly, or you can just use it without filters, essentially in that example. Okay, so that's that was Play as a standalone thing, and I guess I can show you guys just like a normal application. So can you read that?
If you can zoom in, it would be better.
How?
I have no idea.
I don't know.
Oh, this stuff.
I don't know these tricks. Do you guys know how to?
Try Command plus.
Command plus.
Push up and
This
shut.
isn't browser.
I'm trying, but
No.
Except
Enter full screen right down there. Yeah.
yeah, I guess I can do that. Is it better?
no, it's really.
Anyway, I can show the code. So the application structure, as you can see, it's kind of like specific. That's not like kind of SVT project. The structure is that
I don't know if you can change it. You can try.
Stored in the COM folder. The JavaScript goes to public, and then your application is structured in such a way that, like within that folder, you have your controllers folder, your views folder where you keep the sources of your templates, and also if you deal with models, then models go to usually the model.
Okay.
Models folder. Okay, so this is just like a normal kind of like a hello world application. So let me fire up the console. So this is the developer console. It's fine. There. So here you can do a few things. I can compile, and then I can see that like let's run the server. So I'm running the server for 8 applications. Start it up. So I'm now going to make a typo just to demonstrate this developer console idea. So I'm going to make a typo here. And then, as you could see, I didn't have like a separate step to compile. I could compile if I wanted to. I mean, there is like an SVT task defined there. But if you just working like a normal workflow, it doesn't require to run the compile thing, because it's all hooked up when you just hit the refresh in your browser. So as you could see, I didn't execute anything. Now it says that like there's a typo there. Let me go back to my application.
What's that right there? What's that? That's the editor? You're in the Mac, that's an editor?
No, this is the browser.
No, the other one. That, yeah. What's that?
Sublime.
Just an edit. Just text it is a common, very common one.
But anyway, so I fixed the error, refresh the browser, and now it's kind of compiling, and boom, the application came back. So that's the kind of like the on-the-fly compilation thing I was talking about. And as I mentioned, this experience is there for CSS, JavaScript, routing, templates, everything. And so you're going to have exactly the same rapid application development experience, pretty much no matter which part of the application you're dealing with, whether you're a front-end person or a back-end developer, it's going to be the same.
Computer, can I ask you a question?
Please.
Did I get you right that Play is not using any of the available Scala templating engine, but it's using its own proprietary developed templating engine? Is that true?
Yes, that's correct.
What's the name of that engine?
It's the Play. That doesn't have a special name. It's the Play template. But as I mentioned, like because and that was the other thing. These days we have such specific ideas about how we want to deal with the whole development that you have like, oh, I like this tool, I can't live without this tool. So if you like a different templating engine, we really made it easy to that you can just hook it up if you want. So if you want to use a different templating engine, that's fine. If you want to use like a different, I don't know, like a database which is not relational, that's fine. You can just create like a plugin. If you have any library that you would like to integrate, you can have just a core, and you can just create like a plugin really simple and just have your own. Essentially, you can have your own play. I mentioned this Node.js example, but there directly the focus is not so much on the framework, but more like the ecosystem that kind of Node.js has. That was my main point. Yes.
Just to confirm what you're saying, I used Scala with Play 1.2, and I used I tried to use J, but I wound up using their SCAML style template.
Yeah.
So you do have lots of support for that sort of template syntax. Do you have anyone who's working on those style of templates, or do you know if you guys are working on those, or?
Yeah, so the main reason why, for example, integrating those, I used to work on the integration for the previous version. It was really hard because of all this kind of special kind of runtime that Play 1.0 had. With 2.0 is really simple. So when people think that like there's going to be like a special integration for Scala, probably the answer is it's not really necessary. You can really start using it. Just go to your SPP project, add it as a dependency, and so there is nothing special.
It was kind of a bitch. It was kind of a bitch.
Yeah, exactly. But like again, like the main problem there was that because the platform was using all these kind of tricks. That's why like integrating with the existing libraries with the previous version was really hard. And for me personally, like this kind of the fact that like we really stand there, like that's like huge. Like for example, like when we're dealing with like cloud providers, the fact that like we don't require anything special, that's like that makes the whole experience really easy if you want to have like a Heroku support, because it's not like you have to have the Play runtime. You can just really just, you know, we have the dependency in a ID repository, and that's it.
Yes. Is there any support for, you know, when you get some sort of compilation error or any kind of error to actually bring you back to an editor?
I think I don't know, I haven't tried it, but it used to be it was the standard. No, it's
Kind of like
not there.
Eclipse integration.
But yeah, I think if you there used to be there was like a link there, but no, like I mean, right now unfortunately you have to go there.
Is there like an Eclipse integration?
So the way the whole ID supports working, that like we provide this is complaining.
Just straight Scala.
So
actually for the Scala code you have a pretty good integration in Eclipse.
yeah.
Yeah, I use that every day and it's
So
pretty good.
I went back to the console, and I'm going to show you guys what kind of
So that looks like SVT.
You want Eclipsify?
I don't know where.
So that's like a plugin.
You have Eclipsify? This is what you want?
What?
Eclipsify?
Oh yeah. No, I was just looking for the help page that.
SVT has a plugin.
But anyway, so we have for example ID support wise we have IntelliJ and Eclipse support. So you can just say IDE, and that's going to generate like the IDE project file. You can do Eclipse, and that's going to generate this is generated Eclipse project file. So I just generated both an IntelliJ and an Eclipse project file.
I'm sorry, what does that do for you? All of a sudden now I jump into Eclipse and I'm not using the stuff you just showed me, or?
You can use like a different editor, but essentially it just generates the Eclipse project file. So if I go to Eclipse or IntelliJ, then I can open like a project.
Right.
So you don't have. So you can use. In other words, if you don't like, I don't know, Vim or, I don't know, Sublime, then you can just use your favorite IDE as well.
I read about in 1.0 there was a TextMate integration
Yeah.
where if there was a compilation error, you could click in the browser and it would open up the TextMate.
Yeah, that's how I kind of like remember it as well. I don't know whether it's there or not, but yeah, I can look into it. I don't know whether it's not. But yeah, yes. So I just wanted to show like the underlying code just really briefly, of course, unfortunately, because more like it's an intro talk, I can't really go into too much detail, but I just wanted to give you like a sense what's behind the curtain, what's happening behind the curtain. So what you can see here, for example, like you can see the form API, what we have, and also you can see that the def index is there. For example, we just kind of like defining like an action, and within that, the OK thing is returning like a 200, and what's happening like there is really just recalling the generated templates. So if you use Scala or like any other templating language, you have to just basically make sure that, or Velocity or FreeMarker or any templating language available in the JVM, you have to just make sure that like it generates a string, and then you can just pass it to OK, and boom, you will have your template there. So there is nothing special about this. And what's interesting, and I'm just gonna really just mention that you can see that like how forms really handle both directions. So you can define your form, but you also can consume your form in a really elegant way. So you don't have to basically parse like a request and just like, oh, you have name, I don't know, first name, last name, whatever, and then one by one kind of map those fields to like a form. But rather than that, like a form is really kind of encapsulated in such a way that like you really can think about your domain object without like going through this tedious job of defining and mapping and validating forms. So that was it's like a hello world. The next example, yeah, it's gonna be like form stuff, but a bit more complicated. So I'm just gonna show you guys. I'm kind of like a more complicated form. So as you can see, we have all this kind of like validation stuff for example, like email, phone numbers, and other things. So I think that DSL is pretty straightforward, and I can even show the application. But again, like here, the main kind of like I guess takeaway is that now we have like a kind of like we define like a form with like the kind of like standard like validation kind of requirements. So we say that like a phone number should be a phone number, an email should be an email, and again, this is the part where we kind of like handling the for submission. Where we say that like if there was any validation error, then show the error page, and if everything go right, then we should show the summary. Okay, so let's see that application really quickly. Sorry, that's the sign up form. Let me show the content form. So this is the kind of the summary thing. So this was like form handling. Where we tried to pick like examples where we're not really doing the kind of like the traditional like MVC stuff, just to make it a bit more interesting. But of course, as I mentioned, we have like ORM and database support as well. evolution. They also support like evolution of database, managing like database schemes, stuff like that.
I'm a little confused. Where does the HTML and JavaScript come from? The HTML and the JavaScript, where does it come from?
There is a public for their for assets. So the JavaScript is stored here, Scala is stored here, and your templates stored in use. If you're using base template, that's it. That is. So yeah, we can see like a template. So a template that looks like this. Here, the only custom part is that kind of Scala reference to that specific.
Can you configure where your different files are? If you want to change around your directory structure, say you want your files mixed into other places?
Yeah, I mean, I think at this point, the main requirement really is that like things should be in the application folder, but because everything is in SBT, I believe you can override those configuration options. These are just SBT settings, so I think you can override everything. Yes.
So is there SBT settings file in config?
So the way it works is like, I mean, if you're familiar with SBT, so this is the build file for this specific project, and that's the area where you can add your own settings, and that's where you could override existing settings as well. So you could say that like you're going to change the, for example, the application folder, the test folder, something else. But what's happening, because it's like really just like a standard SBT project, we just define it such a way that where we said that like the app folder should be your main Scala classes location. That's what it is, but it's just like a normal SBT feature, so you can override everything.
Maybe you're going to come to my question in some of the examples, but one of the real problems in web-based applications is security, and making sure that sign-up pages are properly encrypted, there's no SQL injection going on, stuff like that. Are there features in the Play framework to help with that?
Yes, that's a really good question. Thank you. So we have like this kind of cross-scripting kind of like security stuff where we generate like certain kind of IDs. So when you submit a form, then we check that that ID is theirs, and if it's not there in an encrypted format, then we're not going to accept that form. And so we escape templates by default and things like that.
So that happens automatically for you. Okay.
Yeah. And the way it works, that like we have like a Play specific configuration file, and when you create like a new application, then we randomly generate a kind of like a key for you, and that's the key that we use to encrypt everything like that. So for example, if you have like a form ID, we use that as a key to generate the secret ID.
You haven't said anything about session management yet. Is the key that gets sent out an encrypted version of something that's in a session object?
So session-wise, like the only thing we have is like an encrypted cookie, and that's the key for that encryption. But we don't keep anything else in the so we don't have like any other notion besides just like an encrypted cookie. The idea is that because we do have like a cache. If you would like to keep like something around, like I mean, you can just use the session ID and keep anything in your cache. But because the whole idea is that like we try to be as stateless as possible, we just don't want to maintain state. Yes.
What's the production deployment look like? Does this create a war file and then deploy production?
That's also a very good question. So underneath the current implementation, the runtime environment right now is using Netty. So the way it works, that like this is the development console, but you can either package it up like the whole thing as like a fat jar right now, or you can just run it with the start command, and then like you get like a PID, and so it's gonna run in the background. It's like regular stuff. One of the things that I was actually going to talk about, like what's coming next after servlet API is so limited in terms of providing like streaming and asynchronous support that we actually have to figure out like what exactly we can deliver with the servlet kind of API. So that's the only reason why we have NetT only, but we will provide like a servlet packaging as well, which essentially means like a WAR file as opposed to a file jar. That's coming right after we release 2.0.
As I see it, what are evolutions?
That's for like managing your database scheme. So
Migrations, basically.
yeah, migration. So I can show you actually in action, but I did that there. All of these samples using like in-memory databases, if they're using databases, so you shouldn't have anything else inspired.
You didn't have evolutions in Play 1.0 or 1.2, did you?
I think now there is like a module that kind of providing something like that, but it's definitely not like for.
You don't have to go into it if other people aren't interested in this.
No, I mean I can show you actually. I think it's a nice feature. So the way it works that the first time you boot your application in dev mode, then it's gonna check whether you have the evolution table created in your database. If it's not the case, then if you're complaining, you can then you get this compilation screen where it says that like oh so you have to run that script. The way it works is generating SQL files. So in production, the same thing will work in such a way that like you would either run evolution when you start up your application, or you could give the SQL file to your admin who could run the SQL file for you. But in this particular case, we can just apply the SQL script and the application started up. So that was evolution. And the next example, so again, like this is something I find really interesting and I'm particularly excited about, and that's like Akka integration. One of the reasons why I'm excited, besides that like those guys are awesome, is that what I always find kind of limiting in web development is providing like this kind of like streaming support, or like at least try to make that as easy as possible. I was always struggling with like providing like creating like command service that I can compose somehow, or like the whole I/O consuming I/O and providing I/O in such a way that like I can create like generic framework to deal with I/O. That was always like really problematic, and one of the reasons why I'm extremely happy about Play 2.0 is because it provides this framework that you can use to deal with I/O. So in this particular example, and I'm not going to really go into too much detail, but I hope I can just give you a sense what I'm talking about in terms of streaming support. I'm going to show an example where this was lifted from the standard Akka demo page, where like we just calculate something. It's just like a normal P calculation and nothing special about it. But what it really represents, this example where we can run some calculation and then we can send the result asynchronously to the browser, and we're just using actors. And here is the application, and you can see that like we have essentially two kind of actions. One action is just showing the main page, and the next one is where the action is happening. And as you can see there is a new thing which we haven't seen before, whereas like an action can have an asynchronous result, and what you see there is that like we send messages to this actor that we just defined, and then we map the result to the response, and we send everything asynchronously over the wire. So I'm just going to demonstrate this really quickly. Of course, the example probably is not the best one, but as you can imagine, this idea can be used for some real stuff, where you have to run like certain calculations, or like a backend job in the background and waiting for the response. So again, all of these examples can be found on the website. So you can just download the whole package and via the distribution. And what I'm doing here is that's exactly what you can do at home. So that's why I thought that these are actually good examples because everyone can try them out. So what we're going to do in this example, this is going to show the kind of like this comment kind of support that we have, which was built on this iterative emulator idea. So what we have here is that we sending over the time as a kind of like a promise, and then we kind of stream the response, and the callback thing is basically the JavaScript function that we pretty much kind of call back once we have the response. And as you can see, essentially this is going to be like a never-ending story because all we do is like we generate the time, and so this is going to happen kind of, and that's way as well as well, I mean, it's a comment service, but everything is asynchronous, nothing is blocking, which I think is interesting. So I'm just going to show that. So yeah, I'm going to show the corresponding JavaScript as well, just really quickly. So this is going to do this. Oh, sorry, this is sorry about that. Yeah, so if you remember, like we had a callback where we defined the specific JavaScript method that you can call back, and that was clock change. I can show you guys again what I'm talking about. So here, when you see that like let's stream that let's stream that specific like action, then we could define the JavaScript callback for that streaming activity, and this is the corresponding JavaScript clock change. That's the one that's basically consuming that.
So it's essentially calling the comment constructor and passing the callback method.
So the time is sent from the server to the market.
Again, maybe not the best example, but we do think that like it's kind of like helpful that if there's like a simple way to get started with the framework. This one is also available, for example, in Java. And the next one. So the next one is gonna show you like kind of like even more complicated example where we're gonna use Akka to implement like a chat room. And what's interesting about this particular example, like you can see now again that kind of comment support that is demonstrated, but in this particular example we go even further because what we're doing here really is that we send data in kind of like chunks. So like you have like an actor that's kind of sending messages between kind of like users, and then it takes this information. So when somebody is writing something, then we send this information to the other user in chunks. So it's kind of like you have like actors that really participating in this whole workflow, which I find particularly interesting. Without going into too much support, I'm just going to run this, but I guess again it's going to give you a good idea what you really can do with the framework. So
how's Apple messages getting to the browsers? Is it the same mechanism for the?
Yeah, so I mean, it's using format to really interact with the browser. But the main difference between this and the other example was that, like here, like essentially what happened was that, like when we got small messages from actors, we kind of map those messages in chunks. We essentially map those messages to chunks and then send that input to the browser, kind of asynchronously. So instead of like the usual like streaming thing there, like you have to wait for everything, you really could deal with I/O in chunks, which I think is really interesting. But let's see what else I will show you before I wrap up. Yeah, I can show like there is a WebSocket example as well. And not surprisingly, this is going to be really similar to the previous one, except because, like, of course, like WebSocket is requiring like a different kind of protocol. Like, so we have like the protocol supported within NATI, and that's what you guys see here. But otherwise, exactly the same idea as far as dealing with I/O. So I'm gonna.
Can you demonstrate like unit testing?
Sure. That's a good idea. I can do that instead because at the end of the day it's going to be like a chat room, so not the other one. But that's a good idea. Let me do that. So I'm going to go to this guy. So this is like a unit test. So we support like functional test and unit test. Now I'm going to show you guys like a unit test. What you can see here is that in your unit test you can mark, for example, the database. So this particular application, so this particular code is running in a context of an application, but it's not running in a context of a running application. It's running in an application context, but not a deployed application. So in other words, like your code is going to be executed in the application context, but not NetEase context. For that, you will need, of course, like a functional test where you would file out the whole thing, and then you could run your test against the real application. This one is just making sure that, like, if your code has anything specific about this application, you can test. This is more like unit testing, where you can mark every single part of your application. So what we have here, we have like a big application. There we can run the controller methods directly and just check that there the controller is doing what we're hoping it's doing. And in this particular case, we just call like one of the methods, which of course in a real context would be happening through hitting a specific URL, where then the framework would figure out which specific method to call. But because now again we don't have native here, we just focus on the specific method that we would like to test. In this particular case, we test the list method, and then we just run normal like assessment, like checking that there, whether the result is what we expected. But this one is really using like kind of like a mock application. This is more like mocking out everything and just focus on your like application logic.
Do you, when you run these, do you run them like from the SPT console, or do you run it from a browser, or both, or either?
That's actually a good question. So in 2.0, we're gonna have only just like the normal like SPT test runner, so you can run it only from SPT or the console. And right after release 2.0, we will provide like a web-based interface to do the same thing. But right now it's only just the console, so sessions should be just organized, just like run like this. And this is going to execute both functional and unit tests. Because our functional tests usually using HTML unit, which is like a command line, kind of like browser, headless browser, essentially. So it's not going to do anything. But if you had like Chrome defined as the web driver, then it would this step would actually fire up the browser and run the test in the browser. Okay, so this so that's the output, and I'm going to show you guys their like the functional test for like integration testing this particular case. So this one is not running in a kind of like a mock context. This is the real deal. What's happening here? We fire up like a real application with a real infrastructure, JavaScript, everything loaded, available, and be using a headless browser to check certain things. But this is again the real application with front end and everything there. So Ajax, you name it. And then like you essentially kind of like testing your application from outside.
Is this integration specific to specs, or does it work with Scala test also?
Oh, it has nothing to do with the test framework. Essentially, like that running